Halide ions can act as reducing agents. A reducing agent gets oxidized in a reaction by having electrons pulled away from it by something else that gets reduced. The ability of halide ions to act as reducing agents increases down the group. As halide ions are less able to hold on to the extra electron as you go down the group, they more easily lose them in reactions and are therefore better reducing agents. Common examples used to show this trend are the reactions of sodium halide salts with concentrated sulfuric acid, H2SO4. The sulfur in the sulfuric acid can be reduced if it comes into contact with a powerful enough reducing agent. Chloride ions from sodium chloride, NaCl, are unable to reduce the sulfur. In the reaction, sodium hydrogen sulfate, NaHSO4, gets formed, and this contains sulfur with an oxidation state of +6. As the oxidation state of the sulfur in the original H2SO4 was also +6, it remains unchanged, meaning no reduction of the sulfur. Bromide ions from sodium bromide, NaBr, are able to reduce the sulfur from a +6 oxidation state to +4, forming sulfur dioxide, SO2. Iodide ions from sodium iodide, Ni, are able to reduce the sulfur from a +6 oxidation state all the way to -2 in hydrogen sulfide, H2S. Again, the reaction has to occur in steps, with sulfur dioxide, SO2, being formed, as with bromide ions. However, this time the SO2 can go on to react with hydrogen iodide to form H2S. This nicely highlights the trend in reducing ability of the halide ions, increasing down the group, and is often a requirement of most exam boards at this level.